Good afternoon. It's the 3 p.m. session on the second day. That's a hard session to get. I'm just saying. I hope everyone acknowledged that. It's after lunch. Everyone are a bit sleepy. We'll try to wake you up with some geeky stuff today. Spoiler alert, we also have AI, okay? In case you were wondering. Thank you, everyone, for joining us. My name is Lior Kamrat. I'm a principal program manager lead in our Adaptive Cloud Experience group, okay? What does that mean? We'll talk about it here in a second. I'm joined by my friend here, Armando.
Hello, everyone. My name is Armando Blanco, so I'm a program manager in the same group, working with customer.
So today's session is pretty interesting, pretty packed. There's a lot of things going on, and we did this session for the first time, kind of not the same content, but kind of the same structure. We did that for the first time at Ignite last year in October, and it went really well. The reason that it went really well, because we were just kind of talking about real things, architecture patterns, things that you can see in the wild. So this session is really about the art of the possible, okay? Now, when we're talking about the art of the possible and things that you can actually do today, and things that you might think of what is it that you can do in the future, that's really what this is all about, okay? So to set some context, okay, this is our agenda for today. We'll talk about multiple architecture patterns, okay? And all these architecture patterns that we're gonna talk about are part of our Adaptive Cloud approach story, okay? And we'll go over what does that mean. You're gonna hear us talking about that a lot, okay? So we're gonna go from deploying application or deploying models at the edge, okay? AI models at the edge. We'll talk about data pipelines. We'll talk about some cool LLM stuff that Armando is going to show us. And then some announcements, some cool things on how to get started and whatnot. Sounds good? Yeah? All right, thumbs up. Already a good start. All right, so what is an adaptive cloud approach? Okay, so when we're saying adaptive cloud approach, to set the context, okay? When we're working with all the technologies that we're working, okay, at the end of the day, all these technologies in every organization that you will find out there in the wild, these technologies are operated by people, right? Now, the biggest challenge is that the fact that these people, these groups of either operations, devs, platform engineering, architecture, right? All these groups are usually, a lot of the time, are still siloed, okay? They're siloed in a way that it's very hard to communicate to the point that things are jelloed, okay? So to me, when I'm talking about adaptive cloud, I have this thing in my head that is about jelloing these groups into one cohesive unit, okay? So that's really to set the context, what is adaptive cloud approach. Now, what you see here on the slide is basically kind of the structure of how we're thinking about things, okay? So adaptive cloud is really, how do we take the things that are on-premises or hybrid or multi-cloud, right, at the edge? What does edge really mean? We'll talk about it here a bit today, right? And taking all these different silos and bring those together into a cohesive pattern, okay? When it comes to deployment of whatever it is that you need to do in order to run your business. So first thing first, like when we're talking about challenges, right? The sprawling system is really the biggest one, okay? The sprawling system is the fact that, you have all these technologies out there, and obviously with AI, I think that things are gonna be, to some degree, they're going to be a bit more complex, okay? And we're going to show a bit of this kind of path to complexity, but also how do you simplify that? But sprawling system is still going to be a thing. That's for sure, okay? Now, these sprawling system, at the end of the day, they are also feeding, right, those silos that I talked about. And the silos that we're mentioning here, they all include processes, okay? So every group, every organization, or every team inside the organization, they have their own processes. The challenge is really to bring those together, okay, those processes. And the third thing is the technical depth. Look, you're doing things, but at the end, it's very hard to decommission stuff, and we all know that, right? You start to implement something, but then it's very hard to get rid of some of things, okay? Either on a code level, right, architecture, implementation, either on the infrastructure side of the house, right? And we also think that that's going to be the case with AI, because you're going to take some directions along the way, and we're just at the beginning of this, right? Some may say. But as you are taking that journey, technical depth will become a real thing in that space as well. So these are really the challenges. Now, the way that we're thinking about this and how to approach those challenges is via adaptive cloud. And the word adaptive is really important here because at the end of the day, right, you can't be just you need to be dynamic. You can't be static. And adaptivity is how we are thinking about this, because as you have those silos, as you have new teams coming in to the picture, new technologies, okay, new implementations, the adaptivity of things is that is the thing that is really important here. So what are the technologies that you're going to implement in order to deal with those challenges, right? And what are the processes and who are the people that you need in order to deal with this? Okay, so that's really when you're thinking about adaptive cloud approach. Adaptive cloud is not really, one product. It's a portfolio of products. Okay, and that's really what makes it very interesting, because you used to come to, to this type of event, right? And I can show you like one product, maybe two products. Hey, we're announcing this, we're announcing that, right? But adaptive cloud is really a breadth of things. There's so many things that are included inside that umbrella, and if you're noticing, right, that diagram that you see here is basically a layer cake, right? You see the top, right, which is basically the operational aspect of things, the management, okay? This is usually where the operational teams, the infrastructure, right, this is where they're gonna fit in. And this is just an example, right? Obviously, this is not limited to the products that you're seeing here on the slide. The second pillar, right, is where we're actually starting to talk about the deployment of the applications, and also how we are making sure the applications are adaptive enough in order to be deployed in the same way, seamlessly, across cloud and edge, okay? And the third pillar really talks about the data. And this is really the important piece, in my opinion, because at the end of the day, when you're trying to basically make sure that your business is running the way it should, you can't do that with a finger in the wind practice. You need data. You need things that you can lean on in order for you to make decisions. And that's what we're going to show today. Now, in the middle of all of this, okay, Azure Arc. Now, Azure Arc, the same as Adaptive Cloud, is also a portfolio of a lot of products, a lot of services, a lot of implementations, features that are included inside that umbrella, okay? So Azure Arc sits really in the middle of it. Now, where does that meet us in this session? Azure Arc, in the context of, Adaptive Cloud, and in the context of Kubernetes specifically, allows us to basically expand our edge, okay, distributed cloud or edge locations, and basically bring Azure services and different implementations to Kubernetes clusters that before that, right, were just kind of siloed. Again, coming back to that challenge that, that I talked about at the beginning, all right? So that's really where Azure Arc fits in, and everything you will see as we are doing the demos, we'll do those sprinkles of Azure Arc, okay? So Adaptive Cloud really, as I mentioned, goes into three sections, right? So the first section is really about the operational aspect, okay? But when we're talking about operational aspect, we also need to think about, okay, how do we do this across distributed estate? And what does that mean? So in order for us to demonstrate, to illustrate the challenges, but also the implementations and that adaptivity concept, okay, like we did last time with this session, we came up with a fictional customer, okay? And that customer is Contoso Motors, right? And they are in the manufacturing space, and Contoso Motors are trying to do better. They're trying to implement technologies, okay, that one, will not create technical depth, but at the same time, will make sure that they're improving their processes, okay? So how do we go about that? That's Contoso Motors. So like I mentioned, this session is really architecture patterns. So you're going to see us bouncing between architecture diagrams and then a demo, okay? So we're going to have 3 of those, right? So this first architecture diagram is the technology stack for Contoso Motors, okay? So you can see, just based on the, all that fancy logos and the cubes and all of that, you can see the amount of technical, or implementations that they already have, okay? Again, I'm connecting the dots here to this adaptive cloud notion that I was talking about, right? There's a lot of things that are included just in their stack, right? So that's Contoso Motors architecture. And what you see here on the, on the top, right? These are just part of the use cases that they're trying to achieve. Okay, so you can see things like welding and pose estimation, helmet, worker safety, stuff like that, object detection. Okay, these are things that literally happen in the real world, in the real life, in the manufacturing space, right? So the first demo that we're going to show is going to talk about how do we actually go by and deploy AI models, okay, at the edge, okay, and how do we actually change AI models on the fly, right, based on customer needs, right? So what you see here is basically a very fundamental, basic flow of a CI/CD kind of flow with GitOps in mind. So this is the first connection to Azure Arc that I want to mention. The cluster that you see on the right, on the far right, that's an Arc-enabled Kubernetes cluster, okay? Because that's an Arc-enabled Kubernetes cluster, it includes a lot of things, but the one thing that I want to highlight is that Flux extension that you see there on the bottom. That Flux extension basically allows us to do GitOps configuration on that cluster. Those GitOps configuration are pointing to a specific GitHub repository, okay? And by listening to that GitHub repository, we're actually able to do GitOps flow on the fly and change some things, all right? So to do that, we'll flip into number 2. And to demonstrate this, we have a sample app. That's Contoso. That's basically the control center for the factory. Imagine, okay, that's just a Flask app. No, nothing too fancy here. And what Contoso are having right here is basically a model, right, that is actually looking at a feed, at a video feed, that is looking at welding. Okay? For those of you who don't know what welding is, it's basically taking two pieces of metal or material and bring them together. Okay? Now, when you're trying to discover defects in that process, right, there is no way for the naked eye to actually do that because we're talking about small pockets of gas that are inside the metal, right, in order for you to actually understand if there is a problem with the welding process. So if you take a closer look, and let me just kind of zoom in here a bit, right, you can see that the model that you see here is actually looking at the video feed that is coming from the machine. And now with this freeze frame, right, you can see here that the class is discovered as normal weld, okay? But if you will notice, you can see that this is changing. And this is based on probability, okay? The model is basically looking at the video feed. But what happens if I want to change that model, and I actually want to deploy a new model at the edge at scale, okay? So let's say how we do that. So in order to do that, and I always like to do these GitOps demos because you can see changes right happening on the fly, and it's kind of cool. So what I'm going to do now, I'm going to watch the cluster that we just talked about. That's the Edge Essentials cluster, okay? AKS Edge Essentials that is Arc-enabled, right? Just a small footprint distribution of Kubernetes that is deployed at the edge, right? And what I'm doing, I'm watching the pods, okay? Nothing too fancy here. But let's see what we can do. So I'll flip here to VS Code. I hope everyone at the back can see that okay. Give me just thumbs up. Yeah? All right, thank you so much. So what we're going to do some changes, right? So the code that you see here is basically the GitHub repository that I was mentioning. Obviously, that's a demo GitHub repository. And spoiler alert, I'll show you how you actually can do that after that session. We're going to make some changes, okay? And we're going to see how those changes are creating on-the-fly process, right? So the first thing that I'm going to do, I'm just going to change the tag of the container, okay? MS build, very original. And we're also going to change the version of the Helm chart, okay, for the Flask application that you just saw, because we are deploying a new version here. And we also have a bunch of other version parameters here that we need to change. Okay, we have basically the main chart, and also we have the nested chart. So now that I did these changes, let me just push those into the repository. Now, remember, because the cluster is configured with Flux, Flux is actually looking at the Git repository. Okay, so let's see what happened. So let's commit that. Whoa. Let's commit that. We're going to say new model, and we'll push that. Now, I'll flip quickly to the terminal here. As I'm pushing the changes to the repository, Flux is actually listening to that repository. And in a few seconds here, you're going to see how the containers are starting to spin up on the cluster, okay? And basically deploying the new container and the new model as a result, okay? That is the part that I'm always worried about. And this is the part when I pray to the demo guys, please GitOps, please work, okay? So that's what you see here. So you can see that the pods are starting to roll, okay? And you can see the change happening in real time. I'll flip back to the application. Let's do a quick refresh here, because remember, we deployed a new version of that application. And what we see here is actually a new feed. And that's a new model, okay? And that model that you see in here is basically an object flow detection, okay? So what's happening right now, there is a model that is looking at the factory line, okay, of bolts, literally bolts. You can see that. And what's happening, the model is looking at the bolts and trying to figure out if the bolts are defected, okay, based on cracks, color, size, different, elements and parameters. So what you just saw is how I basically took a new model, deployed that at the edge, okay, really just via a simple GitOps configuration. So to recap that small and fun demo, that was one example on how you can actually take and do distributed deployments of AI models, okay, at the edge. And with that, I'll flip it over to Armando.
So far, so good? Perfect. So, well, Lior already explained us some benefits and to use Arc-enabled cluster of Kubernetes, but also he explained us other things like GitOps, ARM, Arc, AKS as essential. So basically, we want to leverage the same infrastructure or the Lior's infrastructure that he built, so to create a new application on this. So basically, we create Cerebro. Cerebro is a smart assistant for the frontline workers that Contoso has. So basically, the idea is to help these kind of workers to support, to solve any kind of problems that they have, or if they need to validate, for example, information that they have in their production lines, or in the setup that they have in the machineries, to provide more information of what they can do. So basically, we are using generative AI to help to the users to ask questions in natural language. So this is part of the idea that we have. So the interesting part with Cerebro is basically we are providing some question classification. Because, for example, if you ask questions to OpenAI or ChatGPT, what is the current temperature in my estate, for example, say that it's not possible because it's just information that we have, based on documentation. So we are doing this classification of questions to know if it's something related with documents. So we are using some vector database to index documents, but also we are providing some capabilities to transform the question of the user in InfluxDB, for example, queries to get data from the system that the Contoso Motors has on-premise. For example, InfluxDB, SQL database, or other systems. So, sorry. So basically, we are providing these kind of things. Also, when we get the information, other capability that we are providing is to understand some interpretation of the data, because we don't want to provide just data that is what is the current temperature. So we want to do more data analysis about this data that we are providing, some recommendation for the people. And also, this tool will provide some capabilities to provide more dashboard or understand what is happening with this data. So let me show you the architecture that we have here. This is we are using the same cluster of Kubernetes that Lior showed previously, but we create a new namespace to deploy our application. So basically, the process starts when the user So basically, the process starts when the frontline worker asks a question. So imagine that these people is having some issues, or they need to know more about what is the process that is happening. So basically, we have one application that is Cerebro, that this is the responsible to do this classification of the question. We are using OpenAI to do the classification. So basically, we have a prompt. So we use the question of the user to understand if it's data related or is document related. And then the application routes the question to the correct flow inside of the cluster. For example, if it's something related with documentation, so we have on-premise a vector database that is Chroma. We are indexing the documents, manuals, some guides that this company has. And also, we are using small language models on-premise, the Pi2, that is the model of Microsoft, to contextualize the answer that we are doing. But if it's something related with data, so basically we are using InfluxDB. We are creating some data. And as I mentioned, for example, we are going to create or transform the question of the user to get data from InfluxDB. Also, we have here an assembly line simulator, so because we want to show how we can get data in near real time, because sometimes it's important to say, hey, I want to understand what is happening with the humidity, for example, in this process in near real time. So this is part of the requirements that sometimes we have with our customer. And also, we are using Azure IoT Operation because they provide different capabilities. One of them is the MQTT broker. So basically, part of this process, we are sending data through MQTT. And also, we are the information that we are collecting, so we are using something that is called Northbound Connector to send this data to Azure. So in Azure, so we are collecting this information. Sorry for that. We are putting in Azure Data Explorer to create some dashboard around telematics about the question that the user is asking. So let me show you the demo of this. So what we need to do first to ask some questions to the local LLM. So I have one code here in Python. So I'm invoking the local LLM that I have here, and I'm asking some questions. For example, give me the list of the top 5 best NBA players in the history. No? So basically, I have some answer of the local LLM. I have 5 of these. I don't know, Leo, if you have any question for the LLM that we have here.
I'll ask, how can I make $1 million?
Oh, wow.
I think that makes sense.
Yeah, sure. Let's try to do that. So basically here, oh. I'm going to change the question here. So let's, how I can earn 1 million. Let's save the code, and let's try again. This is not application. This is just to show what we need to do to use the local LLM.
I want to see the answer.
Yeah. Probably you need to keep, still working, you know?
Probably.
Yep. This is just the code to show how we can use the local LLM to get answers. And now I'm going to show the application of Cerebro using the Kubernetes and everything. So it takes around 20 seconds to get the answer. Sorry for that, but this is the, you know, when we want to use the local LLM, so we need to increase the specs of our infrastructure on premise. So well, there are some recommendations for you, Leo. So you need to invest in the stock market.
Take a screenshot.
Yeah, sure. So you need to work hard. So yeah. I think so. Well, now let me show you Cerebro. So this is as I mentioned, this is the cluster of Kubernetes. Now I'm going to show the same infrastructure that I showed in the architecture that previously I used it. So this is Cerebro. So basically what we have here, let me restart the chat. So we believe that the user can ask some questions, typing the question here, but sometimes it's difficult for them because they are, in our scenario is Contoso Motors, they are manufacturing, so probably they are not able to type the question, so we put some facts here. So let's start with what is the oil temperature in the last 50 minutes. So basically, as I mentioned, we are detecting what is the kind of question of the user. So Armando is asking the question, what is the Cerebro answer? So basically, we have some interpretation of this. In the last 50 minutes, you know, the temperature is X. We have some variations. So we are showing this part. We are providing some recommendation about this. It's not just to show the data, but this data is coming from the InfluxDB. And also, we are providing some graphics of this. But also, we can ask other things like, for example, what are the steps to maintain and change the oil in my KUKA robot arm? So I'm going to ask this question. So basically, I'm receiving a detailed guide to change the oil in my infrastructure. So this is what is happening. So let me show you just this part to explain better what is happening behind the scenes. So this is the flow. So we have, we have on top the user asking some questions. So we are doing the classification using OpenAI. depending on if it's data or it's document, so we are going to follow the different paths that I show. For example, if it's document, as I mentioned, so we have running on our cluster of Kubernetes, Chroma vector database. We are indexing some documentation of our customer. And also, when we get the data, so we are contextualization of the response using the local LLM. But if it's data, so we are converting the query or the question in a query for InfluxDB. So we are executing the InfluxDB query, and so we are creating the different elements. To show this process, so I'm going to come back here. So let me clean the chat that I have. I'm going to enable the verbose mode. I'm going to click here. So what is the oil temperature in the last 50 minutes? So basically, I'm receiving the same answer, but if you can see now, the classification of this, I'm enabling the details of what is happening behind the scenes. So I'm receiving the data. What is the query that I'm executing, that I'm running on my InfluxDB? What is the raw data that I have? And also, well, you know the recommendation and these kind of things. But also, imagine some customer has, or they have office in different locations, different countries. If I can ask in other language, it's other thing that I can do. So for example, I have some questions in Spanish. And also, I'm going to receive the recommendation, but now in Spanish. So let me click here. And we are going to get this. So, well, this is the part of Cerebro so we are working with Lior to publish. We are going to talk about this, but we are going to share the code with all of you. So come back to you, Lior.
So when we're saying patterns, okay, so this was the second pattern. The first pattern was the one that I showed you, which is like, okay, how do you actually do distribution of models at the edge, at scale? The second pattern that you just showed, that's the LLM, okay? The third pattern, and I mentioned this at the beginning, is the data, right? Because everything is data. So how does that pattern look like? For Contoso Motors, okay, we want to make sure that they have a good pipeline of data and the right components in place in order to take information that is relevant from the manufacturing line, right? And get their data, ingest that, and then have some business intelligence around that. Sounds pretty straightforward, but there's a lot of components in place in order to make that happen in an efficient way, scalable way, high availability, all those stuff. So when we're talking about architecture pattern in the context of data, it's actually a hybrid pattern, because you're using things that are at the edge, then you do some processing in the cloud, as you will see here in a second with Event Hub, and then with Data Explorer, right? But everything starts with the data that we are capturing from the factory line. So you can imagine that you have things like, and this is why we're showing here IoT operations. You can imagine things like, the robots or the welding machines, CNC machines, and a bunch of other things. Now, the important piece here is that when we're talking about patterns, okay, this is not just for manufacturing, okay? So if you really don't care about manufacturing, that's totally okay, because at the end of the day, right, these patterns, these architecture patterns are really designed to be applied on all types of industries, okay? Even if you're thinking about a restaurant, for example, you have the boilers, you have the ovens, right? These are all assets that generate tons of data. Now, before the edge of, kind of how do I get our data? Like, how do I take the data out of these assets that are deployed somewhere at the edge, right? It's very hard to collect that data. And even if you do, having a process or having an architecture that can actually do something with that data, that's even harder. So I'll hand it over back to Armando. And what you're going to see here is actually how do we take data that is coming from the edge, okay, and all the way, okay, by doing ingestion, how do we actually deal with that data?
Thank you, Leo.
Yeah.
So what we have here, so we are using the same cluster of Kubernetes. So as I mentioned, so for example, we have one namespace here. So we have two MQTT simulators because we don't have here for manufacturing, the different assets that we have in a plant. So we are producing this data using the simulators. The simulator is using MQTT. So basically, we are using, as I mentioned, Azure IT Operation. one of the components that we have in Azure IT Operation is the service MQ, that is basically an MQTT broker. So we are getting this data through this service. So we have 3 different topics around batteries, lines, and welding robots. So we are collecting this information. And then, so we have the other component that is the listener. Listener is taking the data from the MQTT broker and is sending to InfluxDB. So basically, we have here the one implementation of InfluxDB. So we are getting this data. And we create, just to show the data that we are producing 3 different dashboards. So this is around assembly lines. So we can see part of the data that is really common in these industries. So they are care about, for example, what is the product that they are doing. In this case, it's a sedan. If it's electric, this is the data that we are producing. But then also, MQ is using one capability that I mentioned before, that is the Northbound connector, to send the same data to the cloud. So one of the capabilities that we have is to decide what is the service that we want to use in Azure. For example, we can send the data to Event Grid, to Event Hubs, to a Fabric, for example, a storage account. So we have different options. In this case, so we are using Azure Data Explorer. But first, we are capturing this information in Event Hub. So basically, you can see that the data that we are producing on the cloud, so we are using the same component, the Northbound connector, to connect with Event Hub, and we are getting this data. And then, sorry, we are using Azure Data Explorer to produce the same reports that we have on-premise. And probably you are going to say, hey, you are duplicating the reports. Sometimes, when we have different locations, the people that is inside of the plant, for example, they need to see what is happening with your lines, with the asset that they have locally. But probably this kind of reports is more focused on the enterprise people, people that is responsible for many locations. So we are providing different, the concept is dashboard, but we are providing different kind of data here. So this is part of the path that, let me come back to to this diagram. But basically, we are producing the data in the simulation stack. We are using Azure IT Operation to collect this data. Other thing is, so we are using, for now, MQTT simulator, but also we have OPC UA broker that is one industrial protocol that is really common in this industry. We are sending the data to Azure, and basically to produce the dashboard.
Yeah. And one of the things that that we wanted to show you, so you will know that we like live demos, right? This is how we roll. I'm just going to show you something, a bit of behind the scenes. I think you will appreciate that. If I come back to Azure, so Armando just showed you the Event Hub, right? But this is 1 hour, okay? What happens if I do in 6 hours or 12 hours? Oh, sorry, my bad.
Sure.
So I just flipped the filter to 12 hours. You see that dip right there? That's the listener crashing on us about 3 hours ago. So I think you will appreciate the fact that we're able to recover. Okay? So just wanted to show that to you. Okay, cool. See, you got to give the people what they want.
Yeah.
All right. Cool. So we talked about a lot of things, okay? This is a very kind of fast session, architecture patterns. There's so much you can cover in like such a short amount of time, but we still have a few things that we want to cover here. So we talked about 3 architecture patterns. We talked about deploying, okay, AI models at the edge, right, via GitOps. We talked about the LLMs, okay, with Cerebral. And we also talked about the data pipeline of taking data that is coming from assets at the edge, goes to injection, pipeline via, in this case, MQ, okay, all the way to Event Hub, and then, also to InfluxDB and Event Hub, and eventually to Data Explorer for additional business intelligence. So this is how you're thinking about, this is how we're thinking about when we're saying adaptive cloud, right? This is adaptivity, okay? It's by taking real use cases that are sprawling all over the place, okay, and bring them together. I mentioned that concept of jelloing. Okay? And this is how you jello. You take architecture patterns, you bundle those in a way that are touching real use cases in the real world. Okay? So I hope you saw that. So that's really the adaptive cloud. But how do you get started with this? What do you do? I want to do this after this session. How do I demo this to my manager? So for those of you who are not familiar with the project, okay, which is now a product, we actually have a product called Arc Jumpstart, okay? And the Arc Jumpstart is really a collection of goodies, okay? Shameless plug, I wear the shirt, I know, okay? But there's a lot of goodies in the Jumpstart. We have scenarios, automated scenarios, simulated environments, sandboxes, okay? And this week, we're also excited to announce Jumpstart Drops. So Jumpstart Drops is our way to get closer to you. Jumpstart was always about the community, for the community, by the community. Everything is open source out under MIT, right? And with Jumpstart Drops, basically what we're doing is we are taking the brain power that you can bring and actually scale the story, okay? So you can contribute to Jumpstart Drops via a very simple schema, and shortly, also via a very, nice wizard if you're allergic to GitHub. I don't think anyone here is allergic, but that's fine. So that's Jumpstart Drops. Let's see a demo, okay? Oh yeah, I forgot one slide. So here's one more slide. That slide is really about just kind of emphasizing the community aspect, okay? It's really important. I know that there are, I'm joking about this, but because I live it for so long, but the community aspect is really at our core, okay? When I'm saying that, I'm deadly serious. So let's see that in action real quick. How does that look like? And come back here. All right, cool. So this is the Arc Jumpstart, okay? This is the Jumpstart Drops page. This is a new page currently under public preview, okay? We're still rolling out new features, new capabilities. If I scroll down here, you can start seeing the cards, okay? This is what we call drops, okay? These are basically assets that were contributed by the community. We have early adopters, around 90 drops already, and after we released the blog post this week, we already got a lot of requests. Hey, I want to contribute a drop. How do I do that? So we have a very thorough contribution guidelines. But you can see here all these drops. We have a cool filtering. You can go and scroll and all of that. So a lot of the things that or some of the elements that Armando showed you today, some of them are actually already in drops, but I'll show you something that is a bit more comprehensive in the context of the conversation here that we had with you. If, I just want to give you one example here. How does a drop look like? So I will look for, I don't know, we have a drop here. Simulate an on-VIF camera with RTSP. Sounds cool, So I'll click that, and here's the card. And basically, this is just rendering Markdown, at the back end. And you can see here the nice interface. So you have the prerequisite, you have the getting started, and all the details that you need in order to get going with this. So that's kind of nice. And really, you can just go and try this yourself. And we're also going to add more telemetry in the near future. So you will have like trending cards, popular cards, like you go and do shopping on Amazon. Not really, but that's kind of the idea here, okay? So this is really the cards and the drops, okay? So you can also imagine that you can basically add diagrams, you can add videos to those drops, and just kind of create a full experience. And this is your contribution to the community. So that's drops. I'll flick back here, and we have a couple more things here to just cover. So this was Jumpstart Drops. Now, today we covered a lot of things, the architecture patterns, Cerebral, data export, like all this stuff. Now, this is part of actually another product of the Jumpstart, which is Jumpstart Agora. Jumpstart Agora is basically a marketplace of industry solutions, okay, that we are creating for you in an automated way so you can go deploy this, okay, on your own environment and just try out. Now, last year, we started with Agora with a retail scenario. And today, we're also showing, or this week, we're also announcing the manufacturing scenario. The manufacturing scenario actually include all the things, minus Cerebral, that we're working on, all the things that we actually had today and showed you today. So let me show you this in action real quick. So this is Jumpstart Agora, AKMS Jumpstart Agora. Let me show you this real fast. And I'll come back here to the Jumpstart. And this is the Jumpstart Agora page. And you can see that we have the retail scenario. That's Contoso Supermarket. Very cool scenario, a lot of goodies there. But today I'm going to focus on the manufacturing. So this is Contoso Motors. Remember, we talked about them. And what you will have here is basically a very thorough documentations and automations and explanations about the architecture patterns that we talked about. Now, the way that this is described, and if you remember that from my first architecture slide, right? But the way that this is described is basically we go over each and every one of the use cases that are relevant for Contoso Supermarket and take you by the hand and explain to you what are you looking at and how you can actually get going with this, even if you're not familiar with these technologies. So the good example will be, if I'll take here the web UI and AI inference, right? And scroll down, you can see that we're describing the models that we're using. Specifically, we're using OpenVINO model server, right? Intel OpenVINO model server in order to deploy all these models on the Kubernetes cluster that is part of the environment. So that's kind of cool. And again, every document will have its own kind of architecture diagram. Here you can see, I'll try to zoom in here. You know, if you think that, like, this is familiar face, right? This is what we showed in the Walding, right? So you can actually go and do that yourself. We'll deploy the model for you. You'll be able to play with that and all those good stuff. So that's Jumpstart Agora, a super comprehensive bundling of industry automations so you can go and check out yourself, right? So that's Jumpstart Agora. Now, finishing off, let's talk about some announcements that we had in the past few weeks, and one last thing that is kind of cool. Switch back. This is killing me.
Yeah.
All right, I just turned 40. All right. I'm that close, right? Thanks, that's very optimistic. All right, so let's talk about some announcements. I always like to show these type of slides because, you know, we're coming up with so many things, right? There's just so much. It's enough for you to just look at the book of news for a build. It's just overwhelming. So I just wanted to pick a few, okay, that are a bit easy to digest, okay, so for us to have a bit of a conversation around. I'll let you kind of look at this, but I did want to pick a couple of those and just talk about them. Obviously, we talked about drops, we talked about Agora, right? But I do want to pick a couple of those, right? The first one that I wanted to talk to you about is the Edge Storage Accelerator. We actually have a lab that we're doing in this build. We ran a couple of those labs already where you can go and deploy our own first-party storage accelerator. That's how we call it. It's a storage solution for cloud native or Kubernetes, right, at the edge. So you literally can deploy a storage appliance, right? Sorry, a storage extension that is using the CSI drivers, right, at the back end of Kubernetes, and being able to sync data that is on the edge to blobs, okay? So if you want to experiment that, we have a lab. Look for the name, okay? Look for Dale. He sits right here. He's managing the lab, and you can actually go and try that out. So that's Edge Storage Accelerator currently in public preview. The second kind of from all these announcements that I wanted to focus on is actually something that is, you know, near and dear to my heart, which is Video Indexer. So you can see that here, Azure AI Video Indexer enabled by Arc, and also, you know, SLM Pi3 integration. That's a mouthful, but let's talk about it. Let's, you know, just kind of understand what it means. So Video Indexer, for those who don't know, like Video Indexer has been there for a while, right? It's been available on the cloud for a while, but now we also have Arc integration. We actually have that in public preview, okay? Now, what does that mean? It means that we can actually deploy Video Indexer at the edge, okay? For those of you who don't know what Video Indexer, think of Video Indexer basically as a framework, okay? A set of API that is looking at video feeds and able to generate information out of those video feeds, okay? And, you know, the imagination here is pretty vast, right? You can think about millions of industries that can use this type of stuff, okay? You can think about, for example, looking at, you know, maybe, I don't know, like a parking lot, and understand if there is, you know, what is the number of cars that you have in a parking lot, what is the density, okay? If you see a suspect car, that's another thing, suspect behavior, right? So all these security cameras that are looking at these type of places, right, generate a lot of information, okay? When you have an indexer service that is looking at that information in the form of a video feed, right, you can extract a lot of data out of that. So the reason that I'm saying all this stuff is to just kind of tee up a new capability with Azure AI Video Indexer enabled by Arc, and that's the SLM integration, okay? And specifically through Pi3. Now, for those of you who, you know, been living under a rock at this build, I'm sure you heard by Pi3 multiple times, right? GPT, Pi3, you know, all this stuff. But Pi3 is basically just a, you know, a way or SLM that allows you to do summarization. In this case, summarization of the video that you're seeing, okay? So in this example, you just see Satya in previous Ignite or Inspire, I believe. He did the keynote, right? And basically, Video Indexer using PyTree, right, is looking at that video and give you that summarization. Now, this is kind of cool, but if you're thinking about a real use case here, right, you can look at a video feed that usually will take hours, right, to analyze, okay? For example, police departments or whatnot, and then extract information out of that in the same point of time that something actually happened. So that's super powerful, okay? That is really what I wanted to show you today. This is what me and Armando wanted to show you today. Thank you so much, Armando, for joining me.
Oh, thank you.
And thank you so much for joining us. Appreciate the time. Come grab some stickers. They're free. And come have a conversation if you want. Thank you so much, guys.
Thank you.